Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. How is everyone doing today? We are back with the Make Electronics 2nd edition book, experiment number 9, time and capacitors. Okay. Oh, we got electrons travel almost at the speed of light, yet we can use that. You can use them to measure time in seconds, minutes, or even hours. This experiment will show you how. I hope it doesn't take an hour. Alright, guys. That'd be an insanely long video. I put them out there, but this is insane. It says first set your meter to DC volts. Let's turn on the meters, by the way. We got the singlet gear. Let me just show you off the singlet gear here. In the top corner, we got our super jumpy camera here because I got a cable on it. We got our arbitrary wave generator and a meter, a oscilloscope, a meter, a electronic load, and a power supply. So, and I will show you the power supply right now because I am going to set it to the 9 volts we need for this experiment. So we're going to set this bad boy right now. This is the singlet SPD3303X-E. So, and the computer just said it didn't recognize it. That makes sense. Sure, why not? So we got it to 9 volts here, and we got it to 130 milliamps. It's fine. We're not going to be drawing that much electricity on that. I'll put this over here so you can see my meter. So right there, you get the little rays of sunshine. So we're measuring volts DC. We got that all set up. Got the other meter on. So 9 volt battery, 2 switches. Let's get the 2 switches out of our pre-made kit from ProTech Traders. They do good work. Nice little kit so far. Everything's been right. A couple things been a little bit different, like the switches, but you know, that's okay. That's all right. And then we need generic LED, which I'll just get out of my drawer. Got an LED. And then we need resistors. We need a 470 ohm resistor. .470 right there. That is yellow, purple, brown. Boom. Okay, so we got that. And then it says we need a 1K resistor. And the color code on that is brown, black, red. And then it looks like we need a 10K. There we go. Nice 10K in there. And this is brown, black, orange. Okay, and then we need some capacitors. Now I wonder if it wants ceramic capacitors, or does it want let's see, do we even have these in electrolytic? Let's just see what we have in ceramic here and see if it will work with the ceramic. We got a 0.01, a 0.33, and we got a 0.11. We don't have a 10, so we must have to use these. So there's a 10 microfarad. Microfarad, and then we need a We don't need any of these 0.33. There's 100. Okay, so we got 100. What one was this one? This one was 10. So we got 10, 100, and now we need 1,000. We used the 1,000 in the last experiment. Alright, let me get these last two capacitors out, and then we will see. When I went through this book, I used my own components, and mine are organized better. I don't have to open all these little bags. I'm debating whether to do that again. I want to make note, these are pretty similar, so I want to make note. That's it for there. Okay, so that's it on that. So I want to make a note. This is the 104 and the 105. The 105 is bigger, so it's the 1 microfarad. Okay, so we have all our components. I'm going to put them to the side here. We need our breadboard. That would help. Alright, so pull these jumpers out. I didn't pull out last time when I put it up. Okay, so we got our breadboard here. Let's go to the next page and let's see what we have set up here. We have, okay, so we're going to have a little cable. It's going to come in this side right here. So we have a jumper from power. Let's build this right here. We have a jumper from power to that pot right there, and that's going to go to switch A. I'm going to build this all right here, switch A, and then we have our black-brown resistor going from there to there, and then we have a wire. Let's plug this one in there. We have a wire sticking out to measure our voltage on, and then we are going to put okay, so then we're gonna put the big boy in first, and then we're gonna work our way down. So negative, so it's gonna go this way. And then we need another wire for the meter here. Then we need a jumper. Move this over one. We need a jumper from here to here. So that's going to be our other switch. It's going to go in here like so. And now need a jumper from this end of the switch. Okay, so that goes from there to there, and then I need my ground jumper to meet in the middle here, like so. Okay, now if I understand this circuit correctly, when I press this button, power is going to flow through this resistor and limit the current. It's going to flow through this resistor and limit the current. We're going to be able to measure the voltage that is across this capacitor as it charges up. And I believe pressing this is going to discharge the capacitor. So that seems to be the logical path. We're going to see if I get this right or not. Let's get our 9 volts DC. 9 volts DC. Now, I want to check a couple things here. We're going to hook up the meter you guys can see right here. Okay, so you guys can see that. That's the meter going across. That's the voltage going across the yeah, it's going across the capacitor. I'm also going to turn on the oscilloscope and grab my channel 1 cables because I want you to see the wave. See that wave, so I need a wire. Alright, there you guys go. There's the scope. We're going to hook that up to this and then across the capacitor so we can see it's charging this. Alright, and we're going to clear off channel 2, stick with channel 1. We're going to hit auto setup. And we're going to turn this on. Here we go, guys. Let's hope for no explosion. And now we have 1 millivolt. If we press the button, we're going to charge up the capacitor. Oh, we're getting so much noise on the oscilloscope. Okay, so we have 7 volts on the capacitor. Why is that scope channel so noisy? Okay, so if we press this, it's going to discharge the capacitor, so there's no more voltage on the capacitor. So let's go to triggering. let's just go to single. Let's go to setup trigger. Trigger type. Slope. Beginning of the slope. Okay. Let's discharge the capacitor and go back to single and charge the capacitor. Why did it already get my... What's my time scale? Let's see if that did anything. Okay, it says it triggered that time. Let's see. No, did it trigger? There we go. We have the down curve. Let's go back to single. Let's see if we can get the up curve. Now, all we're getting is the down slope at this spot right here. And I don't know why my signal's so noisy. So we're going to cancel the oscilloscope until I hash that out. So we're going to pull the oscilloscope out. Probably needs calibration. Well, actually, it's not noisy at all on the scope itself. Something is giving it a lot of noise. What happens if I hook this wire back up? Yeah, it's getting real noisy. Alright, let's just... should be measuring the voltage across this capacitor. I'm just checking this here. I'm just going to try this one more time here. Okay, here we go. Let's here, I'll just show you on the scope. You can see the charging line of the scope, how it slowly rises. That's the charging of the capacitor, and that is affected by the resistor and the capacitor itself. Let's discharge that capacitor and turn off our power. Make sure that capacitor is fully discharged. It wants to charge back up a little bit, but you can see that the slope of the rising, I can't get a better capture of it. I'm just having issues. It's early in the morning. I got a doctor today. I'm a little stressed. I'm sorry, guys. I'll try to do better in the next video. But changing the capacitors is going to change your amount of time you charge the circuit. So there's a formula of time equals R times C. So in this circuit, it would be 1,000 times 0.001 for the 1,000 microfarad. And it was it's a 1 second time constant. So, you know, knowing that formula, I mean, I should be able to set my scope to capture 2 seconds, and it should capture the whole thing. But it doesn't even say triggered. See, it triggers on the rising edge, but you see, it says it's triggered. Let's see what it did. Okay, so let's... Okay, actually we have a good measurement here. Okay, this I want to show you because it actually worked. My brain didn't fail me. So I'm just going to put this scope back up here so I can show you this. Okay, so this is what I captured. So if we go over here to our cursors, and that's the start of it, and this is the end of it, we get about 2.6 seconds. But if you I mean, it's right about there. But if you come in here and you measure the Y here, you come in here and you measure the Y, and then you go back to X, Y, and then you X and Y, and then you go to track mode, and as you go across, you can see the voltage. So like right there is 2.4 volts as I move up on the time scale. So there's 4.28, 4.6, 5 volts, 6. So you can see how the voltage rises. And if you're doing a logic circuit, which mainly is what I do, then having a RC time circuit in your thing to take away switch bounds and things like that, it's very useful to your project. So, and changing the capacitors would vary that RC time constant. Let me turn off the power, discharge this completely, and pull this capacitor out, and I'm going to touch it across this resistor just to make sure it is fully discharged. Okay, so that was a brown, black, brown is brown, black, red is 1, 0, and 2 zeros. So that's a 1K resistor. Let's put in a 10. Let's put in a 10K resistor and see what we get. Might as well make this forever. So we're going to put a 10K resistor in, and then we're going to put our same capacitor back. We're going to put our same capacitor back. We're going to put our mode on single. We're going to power up the capacitor, power up the power supply, and we're going to press the button. Wow, it is climbing real slow, the voltage across that capacitor. This one could probably be an auto. Let's let it get the... we put the scope on. We're getting this weird thing here. We're going up by millivolts here. We're only at 380 millivolts. So you can see, as if I discharge this, it's 0. So you can see it drop off. Let's let it. Now let's see if we can get it to charge on there. If we can see any kind of curve. Let's discharge it completely. Yeah, this is just too long of an RC circuit. So as you can see, that's not getting up to, that's too big of a resistor. Let's put in the 470 ohm resistor as I do this with a live circuit. Let's not do it with a live circuit. So we're going to put this in here and that in there. Sorry about that. And now we're going to turn our power back on, and we're going to see if this charges. See, boom, that charged real quick. So let's see if we can capture that on the scope. I'm going to catch it in a 2-second. And a discharge. Then we're going to charge. It's not detecting the trigger. See if that worked. Okay, so right here, right there is our curve. Let's get our cursor on there. And that was about 172 milliseconds with that 470 ohm resistor. So there you go. You change the resistor. You can get slower, faster, longer times, whatever you want there. Let's discharge this capacitor. Turn off the circuit. Pull that capacitor out. And let's Well, I mean, I'm not going to swap out a bunch of capacitors. We're already 30 minutes into this. So, let's unhook that. Let's get this out of here. So, it shows you a cool little diagram of what? How it works, pressure, water resistance in a balloon with the whole water thing. You got the RC time currents of R times C is your time. Make sure you're putting your decimals in for microfarad and all that stuff. It shows you an example of the predicted time in seconds of a charge of that capacitor. You can get some voltage distance on graphing it. And then it talks into capacitive coupling, displacement current, some different circuits for different kinds of peaks you want. This is actually something that I'm going to be working on in a different video, and I'll show that to you just to get a quick pulse. Here's a quick down pulse and a slow rise. There's that, and then we have a transistor switch. Is experiment 10. So I'm going to do it for this video, guys. Remember, I use all singlet gear on my test bench. It's on loan to me for 2 months. If you want to help me afford this equipment at the end of the 2-month trial, you can support me on my GoFundMe page in the description, or my Patreon page, which is also in the description, my social media links, and another shot of the Patreon. Thank you so much, guys, and have a fantastic day.